Well, welcome to MV Tutors. My name is Figagasha Manana, and we are doing the June 2023 exam, the Gauteng provincial paper right now. We're going to start with paper number one, question one. Well, let's get right into it. The first one says solve for x given 12x is equals to x squared. Now you should recognize that you can factorize this if you bring everything to one side. So I'm going to have x squared minus 12x, and as you can see, x is the common factor here, so I take out x, and to get x squared I need to multiply with an x, and to get minus 12x, I need to multiply x with a 12. Now I can conclude that x is equals to 0 from this operation there, or x is equals to 12 from that operation. That's it. The next question, 1.1.2, says hence or otherwise. Now this means that use the previous answer or the previous working to solve for this particular question. So use the previous answer. Hence, determine the values of P if given that operation. Leave your answer in insert form when necessary. Now, you should recognize that actually, if we say P squared minus 1 is equals to x, okay, now looking at this operation here, you're going to have x squared, right, is equals to 12x, and then if I bring this side, it's x squared minus 12x is equals to 0. Right, now it looks exactly like the top one. See what we did here? X squared minus 12x, which means we can just go to the conclusion there, because we already know that x is equals to 0 or x is equals to 12. Now remember we said x is equals to p squared minus 1, so we're going to substitute that back. P squared minus 1 is equals to 0, or p squared minus 1 is equals to 12. Now that means that if I take my p squared and my 1 to the other side, just doing some gymnastics there, and then I square root both of them like that, then I have that p is equals to plus or minus 1. Anything square rooted is always plus or minus. I'll do the same thing this side. P squared is equals to 12 plus 1, because if I take the 1 to the other side, it becomes positive. So I have 13 this side, square root both sides like that, and then I will have that finally P is equals to plus or minus the square root of 13. Those are our final answers. All right, let's look at the next question, which is 1.2. All right, 1.2 now. And we are given 5 x squared plus 7x minus 2 is equals to 0. And round off the answer to 2 decimals. Right. So here we're just going to use the quadratic equation. If you do not know it, it's given to you in the formula sheet. Do I have a formula sheet down here? There we go. It should be somewhere here. They always give there. It's the first formula there. So we just write it exactly as it is. No guesswork there. We're just gonna plug and play. So yeah, it's minus b plus or minus b squared minus 4ac divided by 2a. Right. Okay, so now all that's left is for me to identify what's a. That's a. That's b. That's b. That's c over there. So minus b, I always put these in brackets. What's b? It's 7. Right. always put it in brackets, plus or minus square root b again is 7 squared minus 4, open the bracket, a is 5, right? And then c is minus 2. Okay, please be careful to put that negative there, because if you don't, then everything will be wrong. Okay, a once again is 5. Now, ladies and gentlemen, what you want to do from here is bring out your calculator. I got the Porsche calculator. We call this calculator the Porsche because it's so super fast, so awesome. You can do many different things, but I'll keep things basic right now. So minus, open bracket, put it exactly as it is to make sure you don't make a mistake. Plus square root, open the bracket again, put that 7, close it, square the whole thing, minus 4, open the bracket, 5, close it, open it again, minus 2, right? Close it. Then go downstairs, 2, open the bracket, put 5 in there, close it, equals, right? It's set in decimals, so press that. So then I have that x is equals to 0.24. They said 2 decimal places, right? Okay, or x is equals to, now let's go back there and let's go upstairs, go to the side until we get to that plus, delete it, put a minus, and then equals to, change that to a decimal, or x is equals to minus 1.64. That's it. Okay, let's do 1.3 now. Okay, it says solve square root of x plus 6. Make that equals to x. Now with these questions, you want to make sure that the square root is on one side and the other variables on the other side before you square everything. Okay, so that's what we're going to do. Put brackets and square. If I do that to this side, I simply get x plus 6, right? And that's going to be equals to x squared. At this point, what I want to do is just take everything, bring it to one side, so that I have 0 is equals to x squared minus x plus, no, it's not a plus. If you say plus, you are wrong. It's a common mistake. It should be minus 6 as well. And then from there, I can factorize, open 2 brackets, right? Factors of 6, that will give me minus 1. I already know it's 3 and 2. 3 times 2, 3 times 2. Now, this sign is negative, which means the bigger number has to be negative here, which is 3. 3 is bigger than 2, so it remains negative. Therefore, x is equals to 3, or x is equals to minus 2. Now, ladies and gentlemen, when it comes to surds, okay, these questions with square roots, you always have to do a check, always, because remember, a square root can give you a plus or a minus, right? So let's start with the 3 to check if 3 holds up. Remember, it's square root of x, so x is 3 plus 6. Is that going to give me x is 3? Let's check it out. What is 3 plus 6? That's the square root of 9. So square root of 9 is 3, so it checks out. Let's check out the other one now, where x is 2 minus 2. Okay, so it's minus 2 plus 6. Okay, is that going to give us minus 2? Let's check it out. So 6 minus 2 is 4. Is that going to give us minus 2? No. Therefore, we can conclude then and say that x is equals to 3, but x is not equals to minus 2. We reject that one. If you don't reject it, you lose out a mark. You have to do this check in order for you to reject it. Right, let's look at the next question now, which is 1.4, right? And it says use the solution for x in question 1.3 to determine the value of y for which that's the expression. Now, if it says use the solution, that means the solution is the same, which means, okay, x plus 6 is equals to x is pretty much the same as y plus 1 is equals to y minus 5. It's the same thing. Therefore, I can either say x plus 6 is now equals to y plus 1. Okay, if the solutions are the same, that means the things under the square root are also the same, which means just taking the things under the square root will give us the answer. Okay, so x, we solved it here above question, and we resolved it to be only 3. So where there's an x, we'll substitute 3 there, plus 6 is equals to y plus 1. Do some gymnastics. Take the y to the other side. It's 3 plus 6, which gives us 9. If I do the gymnastics, bring the 1 this side. 9 minus 1 is equals to 8. Okay. Another way you could have done it, you could have said, well, these two are the same, where x is equals to y minus 5. It's the same thing. Substitute x, put that 3 there, is equals to y minus 5. Do the gymnastics. Take that 5 to the other side, it becomes positive, so that it's 3 plus 5 is equals to 8. So you could have used any of these. Both of them could have worked. You didn't have to use both. Any one of these would have been fine and quickly. Okay, looking at the next question now, which is 1.5.1. Now let's read the statement over here. A race requires an athlete to run 10 kilometers and cycle 50 kilometers. So he's running first and then he's cycling, right? Okay, I got that scenario. Tendani runs at a speed of x kilometers per hour and cycles at x plus 3 kilometers per hour. He takes 10 over x hours for the 10-kilometer run. Okay, so this is exclusively to running. Now the first question is, express the time he takes for the 50 kilometer cycle in terms of race. Now remember, cycling is 50 kilometers. Okay, and then they told us here that he cycles at x plus 31 kilometers per hour. Now I like to start with the units because the answer should be in terms of time. So then if I say kilometers divided by kilometers per hour, right? Now if I expand this, it's going to be kilometers over 1 times okay, let me just, okay, if I expand it times, now I'm changing the division into a multiplication, so which means that I should take the reciprocal of that. It becomes hours over kilometers. Now check this out. The kilometers cancel each other and I'm left with hours. Okay, so cycling, okay, the cycle part, in terms of kilometers, how many kilometers is he cycling? If you go back to the statement, he's cycling 50 kilometers for 50 kilometers. And at what speed is he cycling at? At x plus 31 kilometers per second per hour. All right, so I can just write hours there. Okay, that's my final answer right there. Okay, and the last question, which is 1.5.2, says calculate the speed correct to 2 decimal places at which he must run to complete the entire race in 2 hours. Okay. All right. So what we're gonna do here is combine everything so that we can solve for x, because it says here the x actually, Danny runs at a speed of x, and that is exactly what they want us to calculate the speed, and that speed is x. So let's combine it. Now I want you to remember something. Why did they ask us this question in hours? It's because we are going to need it in this next question. So let's start with that. Let's combine all the number of hours. So the cycle part, that's gonna be in terms of hours, it's 50 over x plus 31. Okay, let's add the run time. Remember, he's gonna run 10 kilometers. Okay, now the run time, he takes 10 over x hours for the 10-kilometer run. Okay, number of hours it takes to run is 10 over x. And all of this, when we combine the cycling and the running part, it must equals 2 hours. Okay, so we put the 2. Now that completes our equation, which means now we need to do some gymnastics to solve for x. Okay, so here's what I'm gonna do. I'm gonna multiply out everything by the denominators just to get rid of the fractions. Okay, so I'm gonna multiply everything first with x plus 31. Do the same here, multiply with x plus 31, and also here x plus 31. Okay, and then to get rid of this fraction, multiply everything by x, and x. Okay, so what's going to happen with this first one? This x plus 31 cancels that one. This x cancels that one. And then what am I left with? I'm going to be left with 50x on this side plus this side. I'm going to be left with 10x plus 31, which is equals to, and then on this side I'm going to be left with 2x plus 31 times x. Okay, now I have to combine all of these, and I'm going to have 50x plus, multiply that in, I get 10x. Okay, 10 times 31. Let's not make any mistakes. Let's bring out the calculator. I do know what it is, but you know, I want to show you. Plus 310 is equals to, let's start with this bracket. So create a new bracket. It's gonna be 2x. Okay, and then 2 times 31, put it in the calculator. 2 times 31, that's plus 62. Remember, we have an x outside there. And then I'm gonna have 50x plus 10x plus 310. I'm not changing anything this side, just want to multiply everything here. Okay, I'm going to multiply with that, and then secondly, let's start with 2x. 2x times x, it's going to give me 2x squared plus 62x. Right, now I want to bring everything to one side. I'm going to bring everything to the right. such that my equation will be 2x squared. Now let me take all the variables. It's gonna be, right, 62. If I take 50 to the other side, it becomes a minus 50. If I take the 10 to the other side, it becomes minus 10. That's all I have to do with x. So that's equals to, it's a positive 2x. If I take the minus 310 to the other side, that's it. Okay, there we go. Now I'm just gonna put everything in a quadratic equation to solve for x. Remember, x is equals to minus b plus or minus square root of b squared minus 4ac divided by 2a, all under square root there. Okay, so that's my a, that's my b, that's my c. Let me put it in a calculator now. X is equals to minus, open the bracket, what's b? B is 2, plus or minus square root of b is 2 once again, that's squared, minus 4. What's the value of a? A is 2. What's the value of c? C is minus 310. Okay, all of this is under the square root. It's gonna be divided by 2 times a. The value of a is 2. Now we want to put this in our calculator, so let's do that. Minus, open the bracket, put it 2, put it exactly as it is, plus square root, open the bracket, put the 2, close it, square it, minus 4, open the bracket, put a 2, close it, open it again, put a negative 310, close it, come downstairs, 2, open bracket, 2, close it. What's that going to be equals to? In decimal form, so x is equals to 11.96. Okay, or x, let's go back there and put a negative. What happens when we remove the positive sign over there? Let's delete that and we put a negative, or x is equals to minus 12.96. Now we have to reject this one because it makes no sense. So therefore the question, what is the question? Calculate the speed, 2 decimals. Therefore the speed is equals to 11.96. Now what is speed in? Yes, if you said kilometers per hour, then you are correct. That's the final answer. Well, I'd like to take this opportunity to say thank you for watching this. I appreciate it. Please like and subscribe our channel. Bye bye for now. Well, welcome to MV Tutors. We are now doing question number 2 to the Gauteng Provincial June examination for mathematics. Okay, let's get right into it. So it says, in a geometric series, the number of first n terms is given by that formula, and the sum to infinity of this series is that. So it's a geometric series. That's what's important. Now it says 2.1. Let's start with 2.1. Okay, it says calculate the value of k. Okay, so now we have that the sum to infinity of the series is 10. So let's go ahead and look for the sum to infinity formula. You just have to go down to your formula sheet. Where is it? Right there. Okay, let's write it down. Its sum to infinity is equals to a on top over 1 minus r. Okay, so we are, what are we looking for? Okay, let's go back to the question. Calculate the value of k. Oh, over there. Okay, let's just write down our variables. Do we have sum to infinity? Do we have the value of r? And do we have the value of a before we plug it into this equation? So sum infinity, we're given it's 10. R, we know that in a geometric series, whatever is in brackets to the power n, or whatever the exponent is, okay, the fraction inside or the number inside the bracket, that gives us R. So in this case, it's half, and it has to be between -1 and +1 if we can sum to infinity. Okay, now we need the value of a. All right, so we have this formula here. We can solve a, because remember a is just if I'm to rewrite that formula, it's Sn is equals to k, and then we have square bracket 1 minus a half, okay, to the power n, and then close the brackets. Now for a, we have n is 1, right? So then we'll have k, okay, 1 minus a half to the power 1. Okay, what I want to do right now is put this in a calculator. Let's do that. I have a Porsche here. We call this calculator a Porsche, right? I want to put it exactly as it is. Over 2, come to the side, close the brackets to the power 1. And we know anything to the power 1 is 1. Okay, so that's a half. So it's k, and everything here inside is a half. That's the same as saying k over 2. All right, so a, remember this is solving for a. A is k over 2. We have r is a half. We have sum to infinity is 10. Now we can plug everything in an equation. So let me rewrite the equation just in case you don't follow. So we put 10 here under sum to infinity, under a, which is solved it, it's k over 2 divided by 1 minus r is a half, right? Do you remember it? There we go. Okay, let's do some gymnastics now. We'll have 10 is equals to k over 2 divided by, what's 1 minus a half? It is still a half, by a half. But to 1 minus a half is a half. To change this division to a multiplication, k over 2 times, we do the reciprocal of the next fraction, which becomes 2 over 1. The 2's cancel, and therefore I'm left with k is equals to 10. That's it. Okay, let's look at our second question now, and it's 2.2. So happens to be the last one. Calculate the second term of the sequence. Okay, let's go to the formula sheet. For a geometric series in particular, how do you solve terms? There is the term formula there. We're given it's Tn is equals to a r n minus 1. Okay, thank you very much. Formula sheet. Let's go back to the question. Question number 2 right there. Okay, we're looking for T2. Okay, Tn, that's what we're looking for. A value of a. Do we have the value of a? It's what we have to solve. The value of r. Okay, and the value of n. Okay, let's go ahead. The value of a, Now, what is our value of A? Did we solve for A? Sure did. A is K over 2. There we go. A is K over 2. But K, we've solved it. It is 10. So it's 10 over 2, which is equals to 5. And then what's our value of R? Our value of R, there it is. It's still a half. Doesn't change. Remember, this question is following the first one. And then N, it says second term. So our value of N is 2. So therefore, we will say Tn, where there's the N, we'll put a 2. A, we solved A, it equals to 5 times our R. What's the value of R? R, I'll put it in brackets. It's still a half. And then N is 2 minus 1. Okay, ladies and gentlemen, I just want to put this in the calculator exactly as it is. Don't want to take any chances in metric. Okay, 1 over 2. Close the brackets. Oops, gotta go to the side first and then close the bracket. To the power 2 minus 1. It's going to be equals to 5 over 2. Now, did they say anything on how I should leave my answer? Okay, it didn't. Ladies and gentlemen, don't leave your answer in what shall I say, in decimal form if you are not told to. Rather leave it in fraction form. Okay, so that is our final answer. Well, I'd like to say thank you. Thank you for watching up until this far. I hope you learned something, and please like and subscribe to our channel. I appreciate you. Okay, let's do question 3.2 now. It says calculate the value of the sum where P is equals to 1 up until 50 on top. And then we've got the equation is 100 minus 3P. Okay, this means sum. So let's go to our formula sheet and see what the sum formula is. And it's arithmetic. Okay, now, even if you got the above one wrong, but you could have just taken it from above, you know, this question that we just did here, where Sn is equals to n over 2. We are basically using what we just proved to be correct, or to prove what we already know. Okay, now let me scroll up to the question just for semantics. Okay, so there we go. Now let's solve T1. T1, what this means is that we substitute 1 where P is, so it's 100 minus 3 times 1. It should give us T1. T2 would be 100 minus 3 times, where there's a P, we put a 2, right? And then T3 would be 100 minus 3 times, where there's a P, we put a 3. That's how you do these questions. Okay, so here we're gonna go 100 minus 3 in the brackets, we put 1. Okay, I want you to do it like this because I've seen a lot with matrix trying to do these numbers in their heads and then they get the answer wrong. You don't have a chance to get answers wrong in the examination. So just put everything in the calculator just to be safe. Okay, remove that 2 now and then let's delete it and let's put a 3. We get 91. Okay, so from this, what we need is the value of A. Okay, we need the value of D. right? And the value of n to calculate the sum. All right. So value of A is 97. There it is. Solved it. Value of D. D is basically term 2 minus term 1, which is 94 minus 97. Hey, put that in a calculator. All right. I know that some of you don't like doing that, but you like doing it in your head. It's minus 3. Okay. It's very easy to do it in your head and think it's a positive 3. Get the answer wrong. All right. Now, what is our n value? Our n value, we are given as the top number on the sum. This is the Greek letter for sum, Greek letter for S, which means sum. So it's 50. All right, we have everything we need now. S50, that's why it says solve. So we're basically solving for S50. And in our equation, if you look at our equation right there, our Sn equation, it's n over 2, so it's going to be 50 over 2. Oh, there's one thing I forgot to do here. When it comes to the number of terms, you always say plus 1 minus 1 or minus 1 plus 1. Fortunately, this time it gives us 50. It works out to 50. But basically, you have to always do this. Sometimes it doesn't always work out like this. Okay, but anyway, let's go on. 2 times A. What's our value of A? It's 97 plus N. N is 50 minus 1, and D is minus 3. Close that bracket. Okay, I want to put all of this into one bracket. Once in a calculator. Let's see if I can. So we start out with a fraction. Basically, 50, come downstairs over 2. On the side, open the big bracket. Open a bracket, 2. Open another bracket, 97. Close it. Remember, we haven't closed the bigger one, the first bracket. Plus, open bracket, 50 minus 1. Close that bracket. Open another one, minus 3. Close it. Remember, we didn't close the first bracket, so let's close it right now. Equals to 1175. That's our final answer right there. Ladies and gentlemen, that is how you solve the question. Okay, let's look at the next question now, which is 3.3.1. Okay, so we've got T2 minus T1 is 7, T3 minus T2, okay, and so on. Now they want, let's go for A, they want T5 minus T4. So the last one they gave us was T4 minus T3. So all we're going to do here is that now if this is our series 9, 13, 19, remember the difference is just T2 minus T1. T2 is 13 minus 7, which gives us 6. That means the difference is 6. We said 7 plus 6 is 13. 13 plus 6 is 19. So the next one should be 19 plus 6, which will give us 25. So we'll go 19 plus 6 equals to 25. T5 minus T4 is therefore equals to 25. Cool, let's just do the next one, B. right? So B, they want now T70 minus T69. Okay, so now what I want you to notice, our series starts at 7, and we're saying 7 is our first term, right? That's like, if our series is T, then our first term is 7, our second term is 13, our fourth term is 19. I mean, our third term is 19. So you can see we're looking at these numbers, the smaller numbers. So T70 minus T69 is like solving for T69. Okay, but then let's go and see what is our term formula. Just to remind you of an arithmetic, there it is right there. We have it as Tn is equals to A plus n minus 1 d. These are the variables that we need. We need A, we need d, and then we need n. Right, what's our A? Let's go back, let's go upstairs. Let's check what our A is. Our A, once again, 7, same right there. Our difference is 6, and then our total number of the number of values we're looking for is 69. So then we'll solve T where there's an N, 69 is equals to, right? A is 7 plus, open bracket, N is 69 minus 1, difference is 6. Okay, let's put this in a calculator. What? So it's 7, put it exactly as it is. 69 minus 1, close the bracket, and then put a 6 there. That's error. You know what we did? We should put brackets over here. Okay. So let's start again. 7 plus, open brackets, 69 minus 1, close the bracket, open another one, put 6, close it, and that's equals to 415. Right, so now this, therefore T70 minus T69 is equals to 415. That's it. Well, let me just say the question 3.3.2 is unsolvable. It does not make sense. The province decided to take it out, so we are not going to solve it because it says calculate the value of T69, which is basically calculated it. If T69 is that, like, so it gives you what T69 is. At the same time, it wants you to calculate it. It's not make sure, ladies and gentlemen. It's not make sure. So at this time, I would just like to say thank you. I really appreciate you watching this video. Please like and subscribe, and we'll see you on the next question. Well, welcome to MV Tutors. My name is Figagashe Manana, and we are still doing the June 2023 Gauteng Province Paper 1 Mathematics. We are now in question number 4. Let's get right into it. Okay, 4.1.1. It says given f of x is that and g of x is that, show that the turning point of f of x is that. Okay, so what do we know? We know that f of x is equals to x squared minus 2x minus 3. And we know that when it comes to the turning point, the x value from grade 11 is given by minus b over 2a. where that's A, that's B, and that's the value of C. So minus B, B is minus 2 divided by 2 times A is just 1. So it's a positive 2 on top over a positive at the bottom. This equals to 1. Now to get the value of y, basically substitute the value of the x into the original equation, which will be 1 squared minus 2 times 1 minus 3. That is going to be 1 minus 2, which is minus 1, minus 3, which is minus 4. Therefore, the turning point is equals to the coordinate is 1 and minus 4. Well, don't really have to put the equal sign, but it is. That's it. Okay, let's go to the next question, which is 4.1.2. Determine the coordinates of the x and y intercepts of the graph. Okay, to find the x-intercept, we know we must say let y equals 0. So f of x is equals to 0 is equals to x squared minus 2x minus 3. So we're just going to factorize that. Open 2 brackets, values x, and then we're going to have factors of 3. It's 3 and 1. The bigger number has to be negative, okay, because negative 3 plus 1 gives us minus 2. So x is equals to minus 1 and x is equals to positive 3. Now the coordinates, they want coordinates, okay? The coordinates therefore are minus 1. Remember we said the y value is 0, so and the other one is 3 and 0. Now to find the y-intercept, always say let x equals 0. Now once again, our equation is y is equals to x squared minus 2x minus 3, and this time we're letting x equals 0, so we'll have 0 squared minus 2 times 0 minus 3, which means it's minus 3. So our y-intercept therefore is, remember, x is 0 and y, we just solved it as minus 3. That's it. Okay, let's go to 4.1.3 now. This is determine the points of intersection of the graph f and g. That means where they intersect, and where they intersect is where they are equal. So we're going to say f of x is equals to g of x. All right, that's what we're doing. And f of x is given by x squared minus 2x minus 3. That should be equals to g of x is given by x minus 5. So all I'm going to do is just some gymnastics. Put everything in one side so that x comes this side, it becomes minus x. So it's minus 2 minus 1 is minus 3x. That minus 5 comes to the other side, it becomes a positive 5. So positive 5 and minus 3, that's plus 2. Okay, so there we go. Now we need to factorize this. Let's go right ahead and put x on both sides. Factors of 2, 2, 2 and 1. Sorry, just make a mistake. 2 and 1, so they both have to be negative. Okay, and then I can say x is equals to 1 and x is equals to 2. What do they want? Do they want points of intersection? Should I give it in coordinate form? Determine the points of intersection. Well, we can do coordinates. That means just substituting 1, substituting 1 here. 1 minus 5 is equals to into g of x minus 4, and this side it's 2 minus 5, it's 2, it's minus 3. So if I want to complete the coordinate, then that's my x value, which I already knew, 1 minus 4, and here it's gonna be 2 minus 3. That's it. Okay, let's do the next question now, which is basically 4.1.4. Now I took the liberty to draw the Cartesian plane, but what we're going to do is we're going to plot all these points that and coordinates that we solved here, starting with the turning point 1 and minus 4. So it's a positive 1 and a minus 4 right over there. Put a cross. The next one that we solved, okay, is the x-intercept minus 3, minus 1 and 3. So we've got a point here at minus 1 and at positive 3. Put crosses there. And then the y-intercept at 0 and minus 3. So there I'll put a cross. And then the last thing, these were the points where they intersect. Okay, so that was for the graph of f of x. All we have to do now is join these points. Remember, this is a turning point right there, so it turns there, goes all the way up, continues, and then there as well, passes there, it goes all the way up. Okay, and this is the graph of f of x. Right now we just need to put the points for marks. This is 1 and minus 4. If you don't show these, you lose on some marks, so please make sure that you put them. This one is 0 and minus 3. This one is 3 and 0. This one is minus 1 and 0. Oopsie. Minus 1 and 0. Cool. Now let's draw g of x. G of x, okay, first of all, we know that they intersect at minus 1 and at 1 and minus 4. Okay, and then they'll also intersect at 2 and minus 3. Okay, so 2, okay, let me put 1 and minus, it's already there. 2 and minus 3 is right over there, which means my graph should actually pass there. So I'm gonna rub this portion. I have to redo it so that it passes that point. It turns there, it passes that point, and then it goes all the way up, right? Not a smooth drawing, but anyway, something like that. And then for g of x, I just need the y coordinate. So you let x equal 5. I mean x equals 0. If I put 0 there, it's the y is minus 5. So I need a minus 5 here. A minus 5. And if I say let y equal 0 to solve for the x coordinate, I just need the x coordinate and the y coordinate for a straight line. For x coordinate, if I say let y equals 0, 0 x, if I take 5 to, then it becomes 5, positive 5. So right there, and then I bring up my ruler. Okay, so my ruler, no, swing the other way around. Ruler, I need you to pass -5 and then go all the way up to 5. Let's see, that's not perfect. Almost there, almost there. It's just one more notch. There we go. So if I join these points, then that's my graph. Passes there, passes there. Thank you, ruler. Okay, so it actually continues that way. It also continues that way. And this point is 5 and 0. I have to show this intersection, which we solved. It's 2 and -3 is marks for showing that. And then the y-intercept for that graph, which is 0 and -5. So this is my graph of g of x. Make sure you name it, or you can just name it g. Well, that's it. Okay, let's do question 4.1.5. It says use the graph to determine the values of x where f of x is greater, where f of x is greater than 0. Well, I like to say f of x is equal, so I'm looking for where y is greater than 0. So that means the values of y are positive of this particular graph. So I come to this one, that's f of x. The values of y are positive on this graph. I can see if I put my hand here over the x-axis and look above, I can see that the graph from -1 to negative infinity. I can see it as well from 3 to positive infinity. Those are values of x, right? So in writing my answer, then my answer will be, well, actually, where x is less than or equals to 1, -1, and where x is greater than or equals to 0. Now, if you wrote it like this, there is a big argument there amongst mathematicians that if you just say less than and x is greater than, do I write 0 here? My bad. I meant 3. Should be 3. There is an argument that if you don't put the negatives, the equal sign there, then it's still correct. It's out there. They're still arguing about it. It is what it is. Other than that, that's it. Well, now let's go to 4.2. Okay, let's just, where are we? We're on question number 4.2. Write down the equation of the asymptote of f. The graph of f of x is sketched below. Okay, 1/3x. Okay, cool. Write down the equation of the asymptote. Now remember what an asymptote is. It's where the graph wants to touch but it doesn't touch. It goes towards that point but never touches it. So the answer is just simply y is equals to 0 because it never touches where y is equal to 0. That's basically the x-axis. Okay, the next question is 4.2.2, and it says write down the equation of, okay, that's the inverse in the form y. So initially we have y is equals to 1 over 3 x. So the first thing you do is interchange. Where there's a x, you put a y. Where there's a y, you put an x. Okay, so there we go. We've interchanged them and then make y the subject of the formula. Now, when it comes to doing this, you see the base of the exponent becomes the base of the log. So the 1 over 3 goes down there, and then the x comes right there. Okay, that's it. Okay, let's go to 4.2.3 now, and it says sketch the graph of the inverse. It indicates the intercept and one other point on the graph. Okay, so what we're going to do then is that the inverse, remember there's always like well, let me just tell you, the inverse, it's like putting a mirror on the y is equals to x graph. Okay, so if I put a mirror here and I look at the original graph, remember x becomes y and y becomes x. So where we had a y here, then it becomes the x here. So for example, if the y was at 1 here, the graph is going to pass at x equals to 1. And if the asymptote was y is equals to 0, the asymptote this time is x is equals to 0. So everything kind of shifts. So the graph is coming from here. It goes there, it goes towards the y, but never touches it. Right? Well, it's a bad sketch, but what can we say about these things? And then they say write, well, and one other point on the graph. So how do we do that? Do we have another point on the graph that it's going to pass? Well, we can actually solve for one. Just put 1 there so that we have a positive 1 there. So that let's solve for our y. If we say y is equals to log a third and put 1, okay, now let's get our calculator and see what that gives us. So we will go log, that's the log we want there, so that we can put a third there. Let's put our fraction 1 over 3, and then we go upstairs. Let's put 1 there. 0. Okay, so y is 0. You can put a point, but let's try 2. So log 1 over 3. Let's put 2 there. Let's go back. 2. Oh, let's try that in that form. Okay, so it's giving us a negative value. So this is one way of doing it. Well, that's not a perfect number, so let's keep going. I want a perfect number. So I'll go log 1 over 3. I'll put it, let's try 3 this time. Remember, we tried 1, we tried 2. this should give us now a perfect value. Let's see. So we'll go log 1 and 3 there, and then let's put 3 there. What do we get? -1. Okay, so the point I want is x is 3 and y is -1. That's the point that I want to actually work with. So I'm just gonna go back downstairs and name my point 3 and -1. Well, I'm gonna put it, say, maybe there. 3 and -1. There we go. That's it. Okay, let's look at the final question now, which is question 4. Oh, it's not the final question. It's just 4.2.4. Right. Write down the equation of the asymptote of the inverse plus, okay, write it down. 1 x plus 2. Now, I want you to look at something here. Currently, our inverse of the inverse is at x is equals to 0 on the y-axis, right? So if we say plus 2, write down the equation of the asymptote. That means our asymptote is shifting. So because it's inside a bracket like this, it means it's a positive number, means a shift to the left. So that means our asymptote shifts to x is equals to -2. That's it. All right, now this is the real final question, which is 4.2.5. Prove that that is equals to that. Okay, I'm just gonna take the left. Every time they say prove, and there's a left-hand side and a right-hand side, you have to pick one of them and see what it gives you. So on the left-hand side, f of x, and then it's put into square brackets and it's squared minus f of minus x, put brackets, and it's squared. Okay, so what's f of x? F of x is just simply 1/3 in brackets x, right? Oh, why did I put a 3 there? That should be a x. And then outside there, square brackets, we've got a 2. F of minus x, still 1/3. But where we have an x, now we substitute a minus x. And then square brackets 2. What does this give us? It gives us 1/3 2x, because 2 times x gives us 2x, minus this side, still 1/3. 2 times minus x is -2x. Okay, I don't want to confuse you now by making it but you can't, making it like getting rid of a fraction. We can't do that. We can, maybe we should, let's just do it. Maybe you won't be confused. It's 3 minus 2x, okay, minus, and then this one, getting rid of the fraction, it's 3 minus 2x, right? So finally it's 3 minus 2x minus 3 plus, because a negative and a negative makes a positive, 2x. Well, that's what the left hand side gives us. Let's check out the right hand side. The right hand side, on the right hand side we have f of 2x minus f of minus 2x. Okay, so f of 2x, that means where we have a x, we substitute 2x. So now that's 1 over 3. Where we have a x, we substitute 2x minus 1 over 3. Where we have a x, we substitute a minus 2x. Let's get rid of the fraction. This is going to be 3 to the power minus 2x minus 3. Now we've already been through this. A minus and a minus is going to give us a positive 2x. Therefore, the left-hand side is equals to the right-hand side. They're both equals to each other, and we've done the proof. I just want to take this moment to say thank you so much for watching. I appreciate you. Please like and subscribe on our channel. Well, hello there. My name is Fiarahle Manana, and we are still doing the 2023 June examination. This is the Gauteng one, provincial paper for mathematics. We are now in question number 5. Well, let's get right into it. It says, the diagram below represents the graph f of x, and we're given that equation there. T is a point on f. Okay, cool. I see that. By the way, what type of graph is this? Write it down on the comment section. It says determine the values of A, P, and Q. Well, the easiest one to start with is always going to be Q, because it's just the y-intercept one. See right there. So Q is therefore equals to, it passes at 2, so 2. The next easiest one is P, because it's the one passing the x-intercept, the x-axis rather. And we can see it passes the x-axis at 4. Now, should it be minus? No, because they've already put a minus over there, so it shouldn't be a minus 4. It should be a positive 4. Okay, to now solve for A, let's rewrite the equation of this function, which you are still going to write in the comment section what it is. Okay, so here's the point, 5 and 3. So if you have x there and y, I like to do this little exercise because it helps me focus. Under y, I know I'm going to put a 3 is equals to a over, under x, I'm going to put what? A 5. Minus p, we've already determined, is 4, plus q. Okay, I forgot to put a plus q there, but the q is 2. All that's left for us to do is mathematical gymnastics. So 3 remains. 5 minus 4 is just 1, so that's a, plus 2, and then if I take the 2 to the other side, therefore a is equals to 3 minus 2, which is 1. That's it. Okay, let's do the next question now, which is 5.2. It says if the graph, let's read it, if the graph of f is reflected across the line having this equation. Now, what's to note here is that this is the negative line equation. And the new graph coincides with the graph of y is equals to f of x, which it actually does. The line of reflection always coincides with particularly the intersection of the asymptotes. Determine the value of c. Well, if you understand the English in this question, it's just asking us to solve the c in this equation. Okay, so it's going to be y is equals to minus x plus c. How do we solve any c in any equation value, especially the line? We need to substitute a point which this graph passes. Now we know for sure that this graph passes the intersection, and whenever you're solving for c with the line of reflection, you always use the point of intersection. Okay, so the point of intersection is 4 on the x, as you can see, and 2 on the y. Okay, as you can see graphically there. And then all that's left for us is just to substitute these. Where there's a y, I put a 2 is equals to minus. Where there's an x, I put a 4 plus c. Therefore, if I do some mathematical gymnastics, taking the 4 to the other side, let it jump, it becomes positive. It's 2 plus 4, which is equals to 6. And that, ladies and gentlemen, is our final answer. Well, I'd like to take this opportunity to say thank you for watching. Please like and subscribe to our channel, and I appreciate you so much.
Hello everyone and welcome to MV Tutors. I'm Solo and I'll be looking at question 6 with you guys. So this was the exam written 2 weeks ago, I believe. So yeah, we can get straight to question 6, and this is the calculus part. A lot of people are complaining about this paper because it was more on a practical level, especially question 1, where you guys are used to a certain format and this time they switched things around, which is actually quite good, because I think we need to look at maths from a practical point of view, especially for those who say, what's the point? Why are we calculating for x? So yeah, and the practical question we're going to see here is 6.3 or something along those lines. How we practicalize calculus. So let's look at 6.1. It says given f of x is equal to 3x minus x squared, use the definition from first principles of the derivative to calculate the first derivative of the function f. Okay, so if you have forgotten what the formula you're going to use is, it's simply this one over here. All right. Okay, let me selected everything. So basically, the first derivative is equal to the limit as h tends to 0. So, and guys, it's very important for you to continue writing that limit as h tends to 0, because you have not yet substituted the h. So we're gonna go limit as h tends to 0. Let's go back to the function. There we are. Okay, so we can see now in the place of x, we're going to substitute x plus h. Okay, so this is where you score marks. So we're going to have x plus h and then minus x plus h squared. And this is how many marks? 4 marks. Okay, and then we subtract the function itself, which is minus 3x minus x squared. Or let's just put that in brackets. Very important, or else things will not cancel as you would hope. Okay, so there we go. The limit as h tends to 0. We have 3x plus 3h minus, let's just firstly multiply what's happening inside. So we have x squared plus 2xh plus h squared. All right, minus 3x plus x squared. Okay, that is all over h. Why is this boy making noise? He was silent the entire time, and when I decide to record, there he is making noise. Okay, so anyway, we have 3x plus 3h minus x squared minus 2xh minus h squared minus 3x plus x squared. And then we're going to cancel a few things over here. Okay, so we see I can cancel out the 3x, and I can also cancel out the x squared. Yeah, then everything that's left will be in terms of h. I will be taking out h as the common factor. Okay, and if I do that, I'm left with 3 minus 2x minus h, and that will be all over h. So then we can cancel the h's. We're still putting the limit as h tends to 0. This question tends to be quite long, but because of those marks that we are trying to get, we will do the best that we can. And only now can we substitute 0 in h. Okay, and if we do that, what are we left with? 3 minus 2x. Is there a way of checking this answer? Yes, because you can use your product rule. No, not the product rule, sorry. The power rule, where if you have 3x minus x squared, you simply take the power, bring it down, and subtract 1. So in this case, you would have 3 minus 2x. So we are right. We're on the right track. And that is 4 marks. All right, 6.2, determine dy dx. In other words, determine the rate of change of y in terms of x. So if ever you hear rate of change, think about determining the first derivative, okay? dy dx, determine the first derivative. F prime x, get the first derivative. That's just another way of saying it. So let's determine dy dx if, for 6.2.1, y is equal to x minus 3 squared x, or root x, not squared x, root x over x squared. Okay, so firstly we're going to rewrite this because we don't like fractions. We want to write everything on a straight line, if you get what I mean. So let's just change that. So basically we have x over x squared minus 3. Root x is the same as x to the power of half over x squared. And let's just simplify it. So basically you have 1 over x, or let me just put it like this because we want everything on a straight line. We can say x1 minus 2 minus 3 times x a half minus 2. Okay, which is simply x to the power negative 1 minus 3 times x to the power negative 1.5. Okay, and then we can now start to get the rate at which y changes with regard to x, which is the first derivative, dy dx. So we have negative x to the power negative 2. Remember the power rule, take it down and subtract 1. Okay, that is what we are applying over here. Alrighty, and then we have negative 3 multiplied, we're bringing down the exponent, okay, which is negative 3 over 2, and we're multiplying there by x. And then what do we do with the exponent? We subtract 1. So negative 1.5 minus 1 is negative 2.5, or simply, I don't know what's easy, writing negative 2 comma 5 or putting 5 over 2. Like, it's up to you. And then we can simplify it further by saying we have negative 1 over x squared. Okay, yeah, just want to do that. And then we're going to multiply the 2. So we have 9 over 2, and then x to the power negative 5 over 2. If you don't like the negative exponents, you can simply take it underneath over here. So you have 5 over 2. Then you can simplify it further. I don't think it's really necessary, but hey, why not? Why not do it? So we have 1 over x squared plus 9 over 2 root x to the power 5. Okay, that's how you can change x to the power 5 over 2. All right, And so now we are going to do 6.2.2. Oh, snap. I am running out of pages over here. Okay. So let's just add a page. Alrighty. And let's see what we can do with 6.2.2. Okay, now I added a lot of pages. Okay, 6.2.2. So now we have y over 3x is equal to 1 plus x squared. So because we're getting the rate of change of y with regard to x, or dy dx, we want to write your formula or your function or your equation in terms of y. So we're going to bring 3x to the other side, 1 plus x squared. Okay, so we have 3x, and then in here we can just multiply it out and then get rid of the brackets. So we have 3x plus 6x squared plus 3x cubed. Now it becomes easy for us to then get dy dx. Okay, using the power rule, remember we have 1 here, we bring it down. 1 times 3 is simply 3. 1 minus 1 is 0, so x to the power 0 is 1. Then we have 2 times 6, which we bring down the 2, which is 12. And then x, so 2 minus 1 is 1, so that's just 12x. And then we have 3 times 3, which is 9, times x to the power 2. So that is our answer. Okay, now we can get to 6.3. A bit of a practical application, or just not, I don't want to say practical because we're not getting a problem per se, but basically we have function h, which is given by that. So basically you have a parabola and a hyperbola, and it has a minimum value of 12 if x is equal to 2. So just imagine, okay, right now you're thinking there's a parabola, there's a hyperbola. Oh my gosh, so much is happening. Let's just pretend we have a x cubed, or a cubed function, okay, and you have a minimum value over there and you have a maximum over there. Okay, wherever you have minimum and maximum values, that is basically where your gradient is equal to 0. Okay, in this case, we're focusing on our hypothetical minimum value. This is not the function, by the way. I just told you we have a parabola and a hyperbola. I'm just using an example. So with our minimum value, we know that the gradient is equal to 0, or our first derivative is equal to 0. So now when they tell us that the minimum value of 12, if you were to draw this on a Cartesian plane, this being your y-axis, that being your x-axis, basically they're saying at this point you have, okay, so I'm in the negative section, but let's just pretend again that that is 12. So basically your y value is 12, right? Oh gosh, no, I literally drew these the wrong way. Yeah, I didn't think this went through. Okay, so let's just say, yeah. So basically we're there. Ooh, my thing is skewed and I'm drawing in a very skewed manner. Okay, let's just say that value there is 12 and that x value there is 2. Okay, so basically if with x is 2, it's 12, all right? And our first derivative is 0. Okay, so that's basically what the question is saying. So whenever you hear minimum, maximum, don't stress. That just means the first derivative, which is your gradient, that is equal to 0. Okay, so now it says calculate the values of a and b. So let's just write down the function h of x, which is a x squared plus b over x. Okay, and then we know that where there's 2, I have, if I substitute 2 in the place of x, I basically have that. So 12 is equal to 4a plus a half b. I don't like fractions, so I'm going to multiply everything by 2. So I have 24 is equal to 8a plus b. Okay, and that is my first equation, because I realize I have two unknowns in one equation, so that means I need to have another equation. And I'm just gonna put it on the side. I told you, as soon as you see the minimum word or maximum, just know you're gonna work out the first derivative and make it equal to 0, because at a stationary point, that is where your gradient is 0. So let's get this equation and write it out. So we have ax squared, right? And you can say b times x to the power negative 1, right? So that we can determine the first derivative with ease. So we have 2ax minus bx to the power negative 2. And that is equal to 0. So 0 is equal to 2a. In the place of x, we put 2 minus b, 2, negative 2. So we can just write it out nicely. So we have 4a minus b over 4. Because 2 to the power negative 2 is 1 over 2 squared, which is 1 over 4. And because we don't like fractions, we're going to multiply through by 4. And we're going to get 16a minus b. So we can say b is equal to 16a. And that's our second equation. So what I'm going to do now is take the second equation and substitute it into the first equation. So therefore, I have 24 is equal to 8a plus b, which is 16a. Okay, so I have 24, and 8 plus 16 is 24a. So therefore, we can say a is equal to 1, right? Which makes things very easy for us. Okay, so we're going to substitute a into the second equation. Therefore, b is equal to 16 times 1, and our b value is 16. Let me just write that out clearly. So b is equal to 16, and we are done with question 6. I'll see you guys at question 7. Hello everyone, welcome back to MV Tutors. You're with me, Tulu, and we're going to look at question 7 together. So it says the graph of a cubic function has a turning point at A. We have an x coordinate that's negative, and B with a positive x coordinate. The function f has the following properties. So the first derivative, where it's bigger than 0, that's where the x values are smaller than negative 1 and they are bigger than 2. And then where we have the first derivative smaller than 0, meaning where it is decreasing. So where it is bigger than 0, it's increasing. Where it's smaller than 0, it is decreasing. That is where we have x values being in between negative 1 and 2. And then where the function, where the x value is equal to 2, the function is bigger than 2. So now it says draw a neat sketch of f. Clearly label points A and B on the sketch. It is not necessary to show the x and y intercepts. And that is a relief because like, wow. Okay, so firstly, we either have, so 7.1, we either have a smiley face cubic function, for those who have watched my video on cubic functions, that's what I mean by a smiley face cubic function. That's basically where your a is bigger than 0. Remember a, we have y is equal to ax cubed plus bx squared, blah, blah, blah. Okay. And then your sad face cubic function would look like that. Okay, it's sad. All right. So we're not sure yet what is what, but what we do know is the turning points. Okay, so with cubic functions, we have 2 turning points. So we have it at negative 1 and p, and then at 2 and q, because we're still trying to figure out what is happening. Okay. So now they say where the function is increasing, it's basically where x is smaller than 1 and x is bigger than 2. So let's see. This is where the function is increasing. Okay, this is where it's increasing, and this is where it's increasing. Okay, so we can see here it's increasing. X values for where the function is increasing is from -1 to 2, and x values for where this function is increasing, it's basically all the values that side where x is smaller than -1 and x in this direction. Okay, so in this case, this is where x is bigger than 2. Okay, so we can see here just from the first description that we are dealing with this function over here, a happy face cubic function. Okay, so where a is bigger than 0. So we're no longer going to look at this. All right, what else do we know? So where it is decreasing, we can see over here, this is where it's decreasing. That is where x is in between -1 and 2, and that is true. X is indeed between -1 and 2 in this region where it is decreasing. And then it says, so let's just remove all of that. Okay, we have seen where it decreases, where it increases, and that's all great and fabulous. Now, it says where f is 2, sorry, where x is 2, f is bigger than 2. So I know they said we don't have to show the x and y axes, but let's for interest's sake just indicate it. Okay, let me just rub out this. So if this is -1, -1 in P, and that is A. So the y-axis is somewhere around here. Okay. And the x-axis, because we know that at this point where x is 2, the y value is bigger than 2. Okay, so the x-axis is somewhere there. Okay, because this value over here has to be bigger than 2. So yeah, it's higher than 2. It could be 3 or 4 or 2.5, anything, but it would be bigger than 2. So let's just say maybe 2 was somewhere around here. Doesn't matter. So we have drawn a neat sketch. We've labeled A and B, and we are good to go. How many marks was this, by the way? 4 marks. Okay, cool. And now 7.2. It says if f of x, so we don't know what the equation of the function is, but we know that it is a positive cubic function, right? Because it ends up with a happy face. So x cubed plus bx squared plus cx plus d. Now it says calculate the values of b and c. Alrighty, so in this case, we don't know much about this cubic function. We just know the maximum and minimum points, or we know the stationary points, the maximum and minimum stationary points where your gradient is equal to 0. Okay. What you could also do is if you bring down these points, if you were to draw the first derivative of this function, you would get that. Okay, so this x-coordinate would be 2, and that x-coordinate would be -1. I'll put in the link to the video where I do discuss cubic functions so that you know what I'm talking about. All right, so this would be the derivative, the first derivative of your function, okay? And so, yeah. So now when I'm looking for the values of b and c, I'm not going to use the cubic function as it is because there are too many unknowns. I don't even know what the y-intercept is, which would be the value of d. Okay, so there are a lot of things I don't know. But what I do know is if I were to take the first derivative of f, I would get 3x squared plus 2bx plus c, and I would make that equal to 0, okay? Because that is the derivative, the first derivative, which is the gradient, and the gradient at the maximum and minimum points is basically 0. Now we do have the x coordinates of the minimum as well as the maximum. Okay, so firstly, I know the x coordinate where I have -1. All right, so I can substitute that. So everywhere where there's x, I can put in -1. Okay, and that's 0. So I know that this is 3 minus 2. No, I'm missing something. B is missing. Oh gosh. Okay. So we have 2b -1. Okay, so we have -2b plus c is equal to 0. And our equation, if I write it, let's see, let me say 3 is equal to 2b minus c. So that's our first equation. And if I were to then substitute the other stationary point, which is 2, yes, I would then get 3 times 2 squared plus 2b, right? 2 plus c, and that's equal to 0. Okay, so now we have, 0 is equal to 4 times 3, which is 12, plus 4b plus c. Okay, and I will then say 4b plus c is equal to -12, and that. Okay, so this is actually equation number 2. So what I'm going to do now, I'm going to take the first equation and add it to the second equation. And I'm doing that because I can see I have -1 for equation 1. Sorry, I have -c for equation 1 and positive c for equation 2. So if I add the two, the c's will cancel and I have b to solve. All right, you can do it any other how. Remember, this is a interactive platform, so you can just comment below and say I did it this way, still got the same answer, or no, you made a mistake, you're supposed to do this. Let's just see. So if I add both equation, 3 minus 12 will give me -9, and then 2 plus 4, that's just 6b, and then the c's cancel like we said, so therefore b would be -9 over 6, and if we simplify that, that would be -3 over 2. So then I'm going to take this b and I'm going to substitute it in an easy equation, and I feel like equation 1 is the easier of the two. So I'm going to substitute b in equation 1, and we have 3 is equal to 2b minus c. Okay, let me just put it in terms of c. So c would be equal to 2b minus 3. Now I can substitute b, which is -3 over 2 minus 3. So the 2's cancel. I have -3 or -3 minus 3, which is simply -6. And so we have both values of b and c, and we have solved for 7.2. Alrighty. Enjoy the rest of your day.
Well, welcome to MV Tutors. My name is Firagasha Manana, and we're doing the last question of the June 2023 Gauteng examination, paper 1, mathematics. Now, we are on question number 8. Let's get right into it. It says, during an experiment, the temperature T in degrees Celsius varies with time in hours, according to the formula. So that's temperature in terms of time. Okay, that's the formula. And we are told that this formula, it varies from 0 to 10. Okay, the temperature rather, because we can see the temperature. It's actually, if you look at it, the kind of graph it gives, it's a quadratic graph. Okay, anyway, let's read the question. 8.1, okay, it says, determine the expression for the rate of change of temperature with time. Now, with these types of questions, whenever they say rate of change, you always have to remember that it's most likely it has to be, sometimes, most of the times, it is the first derivative of the formula that you are given. Okay, so T, okay, that's temperature in terms of time, is given by 30 plus 40 minus a half t squared. Now, let's get the first derivative like that. You put that one over there. Can't derive a number. This one, it's just gonna be 4. This one, 2, you bring the 2 down, and then it becomes 2 over 2, which becomes 1. And then that's just minus 1. And then 2 minus 1, that gives us just 1. So that's just t. Well, that's it. And then for the final question, it says, during which time interval was the temperature decreasing? Wow. Okay, so we are talking about temperature over here is 8.2, sorry. Just do it nicely. 8.2. Okay, 8.2. We're talking about temperature here. So we know it's a quadratic function and it's a negative one, meaning it's a sad face. It looks like that. That's number one. Now, let's say we have, our Cartesian plane over there. We are told that this graph, uh, it starts at 0, and then it ends at 10. Okay. Secondly, we know that it's decreasing from the turning point there to that way, towards positive infinity, but it ends at 10, so it's gonna decrease from the turning point to and you can see it's decreasing. If you are, say, you're driving your car, right? You're driving your car and from negative infinity going towards positive infinity, and you hit the road there, you start going up, you start increasing, going up, 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 up until you reach the turning point, and then you start decreasing down, 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 down. So in order to do this, we just have to get the turning point, the x value there at the turning point. And how do we do that? We take the first derivative, right? We always take the first derivative and equate it to 0. Okay, take the first derivative and equate it to 0. So we have solved our first derivative over here. Okay, so to get the x value for the turning point, we take the first derivative and equate it to 0. Our first derivative is 4 minus t, equate it to 0 and solve for t. So if I do the gymnastics here, I can see that t is 4. That's just the x value. So the x value there, okay, that's the number 4. So from 4 to 10, that is where this graph is decreasing. So therefore, decreasing from 4 to, these are not values of x. Need to be careful about this. Now these are values of t. Okay, so you can write it like this: from 4 to 10. Okay, or you can say, because sometimes these square brackets means included, you can include it if you want. They won't mark you wrong if you do this. It's still fine. There's still a debate going on out there amongst the maths teachers and the experts whether you should include when this function starts decreasing? Does it decrease at the turning point? Yes or no? Oh, yeah, so it's still a big debate. Other than that, this is our final answer. Or you could have written it like this if you liked, from 4 to 10. Okay, it's up to you, but that's the final answer. Well, a big thank you from me to you, and just like you to take this time to like and subscribe to our channel. We'd really appreciate it, and I personally appreciate you.